to you, Gordon.
Awesome. Thank you. Good afternoon. Hopefully everyone had a good lunch. First of all, I want to apologise. You guys have me for the next 2 sessions, so yeah, strap in. Don't fall asleep. I've got hit my gum, the inside of my gum, so gonna try and speak as clearly as I can. But if there is anything that you need clarified, yeah, we'll take questions as we go. So just as an introduction, there might be people that already know SGN, but just if there are people who aren't familiar, SGN, we're the gas transporter within the Scotland network as well as the southern south of London and the southeast of England. We transport gas to about 5.9 million customers, of what that 5.9 million customer connections, of which is probably about 13 million consumers. I'm part of the innovation team, so we look at new opportunities, new technologies, and try and bring them into the business that offer value within our sort of core operation today, what we do today with transport and methane, but also there's a focus on the future business. As we know, we're in the middle of an energy transition, and really exciting stuff, massive opportunities within sort of green gas elements, but we know there's going to be opportunities beyond the gas networks, so beyond the traditional gas networks of methane. So carbon capture is an area of focus for us. Hydrogen obviously is a big element. Biomethane is something that we're committed to increasing. We've got a sort of 1 million sort of ambition by 2030 to have 1 million customers powered by biogas, and alternative heat strategies as well. There, as a gas network, there might be areas with new customers and areas within the existing network that might point towards alternative solution, district heating, and that is an area as well that we're supporting. So, long story short, we've got a massive opportunity within SGN that we see within the core operation as well as within the futures. And my role is to be the scouting and discovery lead. So I look at new opportunities, new technologies outside the business, and try and match them inside with the challenges of today as well as tomorrow. And yeah, analyse the external market and just make sure that SGN, our strategy is fitted with the way the market and with the way our customers are moving. So on this problem statement, which is optimising riser management, we'll just go into some of the background information. So hopefully people here understand what a riser is. So we supply gas to multiple occupancy buildings. That can be a small terraced house that occupies 4 metres, or it can be a sort of multiple occupancy buildings, the sort of picture that you see there, that is providing energy and to tens or hundreds in some cases of customers. The riser, our asset, goes through the ground up into sometimes a meter box at the base of the riser, or it can sometimes go straight into the property themselves through laterals. They can be externally focusing, so outside the building, and that provides safety benefits. If the riser was to leak, then the gas is emitting into the environment. Not amazing, but it's from a safety point of view, that is perceived as a benefit in the design phase. However, that always can't happen, and it's difficult as well when we maintain and inspect these risers, because often they require different landing platforms to inspect and manage the riser. So they can be internally as well, inside the building, running through the corridors and outside the properties, and then the laterals will be passing through the floors into the customer's premise to their meter box. They are probably the most difficult customer base, most challenging customer base. They can be in socially, or often they're in socially deprived areas where finances and inspections can be challenging for our workforce as well as for the customer. They often are made of iron, copper, steel, or plastic, and they're typically probably about 1 to 2 inches as they run through or up the building. They're inspected, maintained regularly, ensuring we're compliant with the safety regulations, where we monitor corrosion and ensure that the pipe is maintained and in a good health, and there's no leaks and wear. And that can be challenging. As I say, it's difficult to inspect as the asset does run externally. We often have to put some platforms in place to properly inspect that. But yeah, the asset can corrode, it can leak, and it can wear as time goes by. And yeah, we carry out inspections and repairs regularly to these asset bases, but not a difficult asset to get to, as well as a environment with some of the most financially sort of deprived areas, where we just need to be cautious and be really supportive of our customers. Is sometimes they're not the owner, and we have to coordinate through the landlords whenever we're entering this building. So it is a challenging asset as well as a challenging environment. Moving on to the problem itself. So yeah, when we manage these gas assets, it does present significant challenges, as we particularly minimising the service interruption. So if we do cut off an element of this riser, because it is feeding multiple occupancies, that can be a real challenge, especially in winter, where our customers are relying on a safe, secure energy to eat and to heat and stay warm. So it can be a real difficulty to manage that process if we were to require a cut-off. We would potentially have to ensure they have hot heaters and hot plates, potentially put them up in hotels, and it can create quite a significant issue for those customers who just want to stay warm and stay warm in their own premise. And it can often have a vulnerable aspect to it. So I'm sure people know about the Priority Services Register, which is a whole list of people with different vulnerabilities, from financial to physical to mental vulnerabilities. This can be challenging if we are to require a cut-off to manage those customers as well as we support them. And repairs can be challenging. It's often find ourselves in confined spaces when we carry out this repair. So some things that work in reality on the test bed at laboratory can be difficult to translate that into the real environment. No riser is the same. Sometimes it does require bespoke solutions, and we do have a toolbox of different solutions within the box for repairing these risers. One innovation that we progressed was microstop, which basically, if there's a leak on the riser, you can bypass that while maintaining the gas to our customers, so we don't need to cut off. However, that's not always used through the configuration or the asset itself. So there's opportunities to broaden the envelope in terms of how we repair within the confined space element. But it can be difficult with how bespoke these risers are. And then big issue as well is the inspections. It can be really difficult to inspect not only scale and the location, just the sheer number of these risers can be challenging to inspect, and we often send out our operatives to carry out these inspections, and they'll do visual inspections, and it can be difficult for them to put in a platform, especially if it's in the external environment, where they are actually having a good look at it. And there are some solutions, but we've not approved any on drones and robotic solutions that does do that inspection, but there's an opportunity there. But yeah, it can be very challenging to inspect these ones due to the sheer number as well as the location. So what we're sort of looking for, and this is prescriptive. It was really good to hear some of the new approaches from the ENA and the SIF team, where we're looking to do more of a workshop to really root out these problems. But this is where we see some of the solutions going, but it should be marked that it's not limited to these, as we figure out more on the specific issues as those workshops progress. But the goal would be to develop advanced live repair techniques that can ensure safety, cost effectiveness and long-term durability while maintaining continuous gas flows, so that we're not adversely affecting the customers downstream. We are seeking new and creative ideas that will enable that live maintenance and repair without disrupting, especially for copper risers, which is a bit of a challenge for Microstop. The previous solution that I mentioned is not approved yet. We could look at utilising advanced materials and technologies or methodologies to enhance that repair efficiency and effectiveness, and then smarter inspection techniques as well is one that I think would solve a few problems. If we are to repair the leak or cut off the supply, there might be opportunities as well in terms of managing the customer, where we could look at software solutions or hardware solutions that would improve the customer service as well. And just to mark some of the solutions, we're thinking they must adhere to stringent safety standards. That's gas standards, but it's also the property safety standards as well. So yeah, we need to adhere to them. The techniques must align with the legal requirement as well as the gas industry standards, and then they must be feasible in the various environments, including areas with limited access or confined space. As I said, the riser solutions are real. The riser sort of asset is so diverse, from Scotland to the south of England. We need, it would be nice to have one solution that fits all, but it's probably not practical given the diversity of the environments. So yeah, we need just that solution to be able to work in various in different environments with limited access or confined space. And just a point as well, with these risers, there's been a good bit of work done from my colleagues at SGN and the other gas networks, proving that hydrogen can be safely passed through these risers. So we definitely see this as a sort of long-term asset that we will need to manage, maintain, and inspect as we progress from methane to green gas like biomethane, as well as hydrogen in some cases as well. That decision is to be made on what the EIP policy is in 2026, but the evidence is there to suggest that we can transition these to hydrogen. So that's really the cusp of the problem that we're trying to solve here in terms of repairing and inspecting the asset. Just want to stress how difficult it can be with the diversity of the customer base, as well as the environments that the risers go through. But yeah, we're up for hearing and working with different innovators within this space who have gas experience or no gas experience. This is a very difficult challenge that's going to continue throughout the years, and one that we definitely want to help, especially those vulnerable customers, progress through the different repairs and inspections, make sure they are safe and warm as we maintain the asset. So yeah, thanks very much for listening to that one. I think we'll open it up to any questions that we have on the repairing and the management of gas risers. There.
Someone's got to go first.
Someone's going first. So, do you have any ideas on this? Where have you got to so far?
So we want to keep it open to the solutions. So it could be software, it could be hardware. We have worked in this space and been innovating to create solutions that would minimise the disruption. So the project that I mentioned in the Microstop space is implemented within SGN, but there's definitely solutions and possibilities still. We've not managed to minimise all cut-offs. So that's a really bespoke area that we could focus on. But yeah, we've got previous work in that space, and as I said, the hydrogen work as well is ongoing. But I want to keep this open to solutions. It does need to be different thinking. I think we have exhausted a lot of the gas innovation in this space, and yeah, this is the point. We want to open it up to different thinkers and yeah, go beyond what we're currently doing. We do have a list of toolboxes and solutions in our toolbox, but yeah, in terms of and repair, there's definitely areas that we could innovate in. In terms of inspection as well, there's potential. So water companies employ Uber to monitor gas leaks as well. Is there a customer solution that we could improve our inspection rate through something similar to that, where customers would potentially jump and take pictures of the risers that would give us better intelligence as we come to manage and monitor the inspections. But yeah, don't want to prescribe. I think we are open. We've got a wide open here in terms of hardware or software solutions. Maybe it's economic models as well in terms of the financial vulnerability. But yeah, we want to get that conversation started and see what we can do in this space.
Got a question over here?
Hi, Cara Hazelgrave, PNDC. I'm just wondering about, I know you use cameras within your pipes already. Are the pipes too small to use cameras in, or have you looked at internal, running something through it to inspect?
Yeah, where the internal inspections, yeah, they can go down to 1 inch. So we can have crawlers that can go through the service main, as well as some of the risers. I'm not sure we've got any approved where it goes up and it will inspect inside. Where we get most of the interest is in the outside, the external inspections, taking visual inspections. But I don't think it is something that we've looked at. The technology is there. But yeah, it's something that maybe we could explore in terms of putting that up the riser as it increases. There has been something as well, and I think it was Town Gas have innovated a sort of crawler on the outside where it would inspect and run up the main, which again, yeah, is something that the technology is there, and maybe it is more a trial in that phase as opposed to a development of a new solution. But yeah, the technology is there, and the size of the cameras wouldn't be an issue, I don't think.
Probably got time for one more question.
Oh, do you want to answer that? I don't know.
To be fair, mine was just a point off the back of the question. Sorry, you just can't say. Sorry, I was just going to come in from the gas perspective just to back up what Gordon was saying on that. Obviously, like Gordon said, it's around an inch. We do have service cameras that go all the way down to 20 mil. So we do have that, but the difficulty with it is obviously going vertically, going up, that you'd still have the difficulties that you'd need the platforms and everything like that to gradually rise, because we wouldn't really be able to put the service camera more than a few meters upwards, because then it just starts to kink and you have issues like that. So no, there's not really anything out there at the minute that you'd be able to do, especially on the sort of the high-rise ones that Gordon had pulled up on there, that would cover that. So yeah, definitely looking for them.
Yeah, well, we've got time for an extra question, don't worry.
Cliff Walton, I'm sorry, this is going to be a bit more controversial in a sense. I understand that you want to do the inspections and that's what you're asking for, but my question really is should we be doing this at all? I mean, should we be having gas in high-rise buildings? I'm thinking of Roland Point and the disaster that was, and I wonder whether maybe you should be using those assets for something else, taking it down to ground level and providing the heat and the energy somewhere else. So it's not answering your question, but it's perhaps more challenging for the long-term future.
Yeah, so we've provided evidence to prove that these risers could be transitioned. That will go well to the government along with other repurposing options. We have had research done in terms of how we could repurpose this for district heating, and there is a colleague of mine that works in looking at how we could repurpose a gas riser using waste streams, creating a heat network, using the asset and providing clean energy. The long story short, that can be done in some cases, and what we're seeing is this is going to be around these risers. People don't have the finances with this customer base to create these transition clean solutions. These aren't going to be ones that are going to be buying heat pumps or investing in the infrastructure, and I think this is going to be around for a long time. The repurposing for a different solution is an interesting one, and but I think this one is trying to solve what we can do today. Because these assets are going to be around for many years still to come, and the opportunity for helping those customers is definitely big enough for us to make an impact to those customers' lives that live there. So yeah, I think the question on whether these are going to move, what the clean energy source is up for debate. We need to provide the evidence and then make a decision based on what is right for that base. Is it using a waste stream? Is it district heat? Or is it hydrogen? That will probably need to be done at a local level. Yeah, the problem that we're faced today, that our customers are facing today, they don't want to, they need their asset that's running through their building inspected and repaired, and as least disruption as possible, and that's what we're trying to solve with this one. But I think 2026 is the evidence for the heat policy, and I think it will be a sort of local, what is the best solution for that type of riser, because it is so bespoke. So yeah, that'll be interesting to see how that progresses over the next few years or so.
I think that is all we have time for, so a round of applause.